Hello folks, if you hear my dogs, just ignore them because I'm doing this live from the house. This is kind of what our lessons are going to look like, and they'll each be approximately 5 to 10 minutes is the goal. So we're going to start with topic 7.4, which is similarity in right triangles. And the objective is I am learning to find and use relationships in similar right triangles. And this will be iLearn11's notes. And the assignment is on Google Classroom as well, as you can probably see. So geometric mean is basically a proportion where we're going to be cross multiplying. The proportion is a over x equals x over b. And what this is what I call triangle mountain. And it's a right triangle that you turn where its base is the hypotenuse. And the x value that we're going to talk about is going to be called the altitude. And the altitude is a measure from the right angle to, and that's the intersection of the two sides that form the right angle, to the hypotenuse where it is perpendicular, the intersection of the altitude and the hypotenuse. For example 1, the geometric mean would be if this distance is A and this distance is B. By the way, those are interchangeable. A could be 4, B could be 18, or vice versa. X is going to be this measurement that we talked about a second ago. And then A, which is 4, B, which is 18, are going to be substituted into this formula. And A is 4, X is unknown, and then B is 18. Just like we talked about before, you're going to be cross multiplying on this. So when you do cross multiply, x times x is x to the second power, not 2x. 4 times 18 is 72. And then to get rid of the squared, you have to do the opposite of raising something to the second power, which is square root. So we'll do that on both sides of the equation, and we will get x is equal to the square root of 72, which does simplify. We want all these things in simplest radical form unless otherwise stated in the directions. After you have that, you could either do the homie method, or the shortcut is the largest perfect square that goes evenly into 72, and then whatever you multiplied by that largest perfect square to get 72. So what I do in the calculator is I take 72 and divide it by perfect squares. So for instance, 1 times 1 is 1, 2 times 2 is 2, 2 times 2 is 4, 3 times 3 is 9, and so on. And the largest one that's going to work is actually 36. So that would be the square root of 36 times the square root of 2. And the square root of 36 is 6 square root 2. And that would be your final answer, 6 square root 2. You'll repeat this process for example 2. So I'll do that one real quick for you. Again, A and B are interchangeable. So once we set this up, it would be 8 over x is equal to x over 6. And you would cross multiply it. When you cross multiply it, you'll get x squared is equal to 48. And then you'll take the square root. You'll get x is equal to, again, if you use this little trick, divide by the largest perfect square that goes evenly into 48. And that factor would be 16. And then 16 times 3 is 48. Or if you wanted to do homie method, you can. That's the prime factor tree. Now once you do that, you want to simplify and you'll get 4 root 3. Example 3, you have A, you have x, you're looking for b, so you want to substitute those in, and whenever we do that, we will get 5 over 20 is equal to 20 over b. And the unknown is b, we still want to cross multiply. So you'll get 5b is equal to 400, and then you're going to divide both sides by 5. And you'll get b is equal to 80. Example 4, this is where we're going to change it up a little bit. You'll notice that we can still solve for x, and we can do that the exact same way that we have been working on. I like to just ignore y. And then for x, what we're going to do is repeat the same process that we've been doing. So now we're going to cross multiply, and we'll get x squared is equal to 20. Take the square root on both sides, and you'll get x is equal to square root of 20, but if we were going to do simplest radical form, 4 and 5 give me 20. 4 is your perfect square. So that would give me 2 square root 5 whenever I simplified. Now that's just one of the variables. You also have to solve for y. And to solve for y, there's a little trick. Y is on the same side as a. Those are going to go together. You still would do just like we did 4 over x. This time we're going to do 4 over y. And y over, do not put 5. Now when you're solving for either the y or this value, sometimes called z, or any variable that you want to use really, you want to put it over the entire length here. So that would be 4 plus 5, which is 9. And I'll do one more example like this. We're actually going to skip example 5. I'll do one more like this so you'll know exactly what I'm talking about. So that 9 is what goes here, not the 5. When you cross multiply, you'll get y squared is equal to 36. Take the square root, you'll get y is 6. And that's completed this problem. Now the other example that I'll do, I'll solve for all 3 sides here. I'll solve for this x, which is the altitude, the y, and what we'll call z. But again, it could be any variable. So I'm going to call this example 6. I know we skipped 5. So here I have Triangle Mountain, and we have x, y, and z. Now I'm just making this up. This problem will be given to you. The directions are find x, y, and z's value. So to find x, we would use the traditional way that I've shown you multiple times now. Cross multiply, and you would get x squared is equal to 48. Take the square root, and again we would get 4 root 3 after you simplified square root of 48 as 16 and 3 as previously stated. Now for y, again, the y will go with whatever the a value is. So we'll say 4 over y is equal to y over, remember I said it has to be the entire distance. So 4 plus 12 is 16. And then you would repeat the process that we've done a number of times, and you would get y is 8. The last thing is solving for z, and you probably predicted this, but z will go with 12 since they are in the same location. So 12 over z is equal to z over the entire length of the hypotenuse. You may be asking yourself, why are we using the entire length of the hypotenuse? Well, without getting too confusing, you actually have 3 triangles here. You have this one, you have this one, and you have the large one. And those all 3 are similar. So all you're doing is setting up a proportion for similar right triangles. Hence the name of the lesson, similar right triangles. So we'll get z squared is equal to 192. And if you simplify, you will get, I believe 64 times 3, which would be 8 square root 3. I'll be putting more lessons like this on Google Classroom for you and on YouTube. Plan on doing a live stream and giving you all the notes, a blank copy and my finished copy, as well as all the assignments.